Okay, acceleration. Here we go. We're doing acceleration question 1. We got some weird numbers. It's something we're not used to, but it's going to be just as easy. So, here we go. A ball rolling at 4.80 meters per second over the ground when it is rolling over the ground when it encounters a ramp, which gives it an acceleration of negative 0.875 meters per second squared. If the ramp is 0.75 meters long, what is the final velocity of the ball when it reaches the ramp? Okay, so that's a lot. Let's highlight stuff. Highlight numbers that are probably important. I see it's rolling at this. What that tells me is, remember, if it just says, yo, hey, it's rolling at this speed, that's its initial velocity. That's not final, it's initial. Hey, it's just rolling at this speed. Initial velocity. When it encounters a ramp, which gives it an acceleration of negative 0.875. Let's look at two ramps here. If I have a ramp like this, and I have a ramp like this, if it's rolling and it slows down, which ramp do you think it hit? Well, it's rolling and hits this ramp, it's going to speed up. If it's rolling and if it hits this ramp, well, this is going to suck some of that momentum and slow it down, right? So in that case, it probably hit the bottom ramp, a ramp like this, just as an FYI, okay? And then they tell us that the ramp is this long, 0.750 meters long. Awesome. We want to know the final velocity. Okay, cool. So let's write our numbers real quick. So initial velocity is 4.8 meters per second. Acceleration is negative 0.875 meters per second squared. Notice that it's not 9.8 meters per second because it's only 9.8 meters per second when it's falling, because that's the gravity's like pull, 9.8 meters per second. Since it's rolling and the speed changes acceleration. That's why it's not 9.8, it's whatever they give us. So acceleration is 0.875, and then the displacement, or actually the distance, displacement, 0.75. You can say 750 or 75, it's all the same, meters. Okay, we want to know the final velocity, so let's get our handy chart out. So let's look at what they give us and figure out which one we need. So we have initial velocity, so let's look at these four right here. We know, because we want a specific point, which is a final velocity, we know we're not using this average velocity one. Okay, so we can forget about that one. So let's look at these three. So we have initial velocity. So I see initial velocity here, I see it here, and I see it here. So that's good. So that still keeps all three in the game, right? I know that, let's bring this up just a little bit. There we go. I know that, we also have acceleration. So I see it here, I see it here, and I see it here. So they're still all three sort of in the running, right? And then I know that I have displacement. So this one does not have displacement. This one does, and this one does. So now we need to look at the difference between these two. With these three, we need final velocity, which they have here. This one doesn't have final velocity. Ooh, I hope I didn't say that a second ago, but if I did, whatevs. I only see initial, this one has final, so this is what we're going to use right here. Let's write our formula. Acceleration equals our final velocity squared. Cannot forget about this. This is where everybody screws up. They forget the squared. Minus the initial velocity squared over 2 times the displacement. Cool. Now we plug. Acceleration, negative 0.875 equals, what's our final velocity? We don't know. Final velocity squared, can't forget about that, minus initial velocity. What's our initial velocity? 4.8 meters per second. 4.8 meters per second squared over twice the displacement, which they tell us is 0.75, because that's the whole ramp. 0.75 in parentheses. Okay, so now we got to do everything we need to do. So let's break this up into a couple steps. We're going to go right here. 2 times 0.75. So this is like 75 cents times 2, which should be 1.5. Right? 75 cents times 2. Next thing we need to do is this 4.8 squared. So 4.8 squared times 4.8, so 4.8 times 4.8, which is 4.8 squared, should give us 23.04. So we have so we have velocity, final velocity squared, minus 23.04 divided by 1.5 equals our acceleration. I'm going to kind of write it small as negative 0.875. Negative 0.875 equals all this. So same thing if you can follow it here. I'm going to rewrite it again. So we have negative 0.875 equals our final velocity squared minus 23.04 over 1.5. Woo! We're getting there. So next thing we need to do is we need to get rid of this denominator because that throws a wrench and everything, right? So we multiply the right side by 1.5 and the whole thing in parentheses, that cancel, which means we've got to multiply the left side by 1.5. So we're going to rewrite it again. So we should have, let's do it, 1.5 times negative 0.875. So we should have negative 1.3125 equals final velocity squared, still can't forget about that square, minus 23.04. Ooh, okay. So we're running out of space, we're going to make it. Next thing we need to do is get this by itself. So let's, since it's minus 23.04, it's not multiplying, it's just subtracting, let's make this equal 0. So we're going to add 23.04, which means we can cancel this out. We're going to add 23.04. So go ahead and do that. Okay. All right, so negative 1.3125 plus 23.04 is going to give us 21.7, and we're just going to round to this many digits, so 21.73. We're going to go ahead and flip it so I can get this variable on this side, so we're flipping these. So we're going to have the final velocity squared equals 21.75, right? We are not trying to find the final velocity squared. We're trying to find the final velocity, right? So what we have to do to get rid of a square is to do pretty much the opposite of a square, which is a square root. So what we got to do is we have to square root this side, which is going to give us, so I'm going over here, right? It's just going to give us the final velocity. So there's no more square, which means we have to square root this side. So if we do one, we got to do the other. Let's label this. 1, 2, 3, getting tricky, 4, 5, 6, 7, which is our final one, right? So we square rooted the final velocity, which give us final velocity with no square, which means now we got to square root this 21.73. So our final velocity should be 4.66 meters per second. If you got lost, rewind. All you need to know is the right formula to use, which is this one. I guess I got to move it back up. We use this one right here. Do we use this one? No, we didn't. We used this one. So we had to square stuff. Plug everything in. Use your basic algebra, which you've probably had years ago, and you will get the answer. All right, guys, good job.